Absolute value inequalities. So first of all, absolute value is just distance from 0. Right? So if we have the absolute value of x is less than c, that means its distance is less than c in either the positive or negative direction. It's equivalent to saying that x is greater than negative c, but less than c. And that's exactly how we'll solve that inequality. The absolute value of x is less than or equal to c is solved almost the exact same way, except the endpoints are included, because we can also be equal to c or negative c. Right? So we can be no more than and including c away from 0 in both the positive and negative directions. If we have the absolute value of x is greater than c, that means that x is either less than negative c or x is greater than c. We have to be more than c from 0. If it's the absolute value of x is greater than or equal to, then those endpoints are also included. And it's equivalent to saying x is less than or equal to negative c, or x is greater than or equal to positive c. And of course, we're assuming that c does not equal 0. Otherwise, well, we really wouldn't have an inequality to solve at all. Let's look at this first one here. Solve the inequality x minus 5 is less than 2. All right, so notice we have a less than. That means we're sandwiched in between 2 and negative 2. So when we rewrite the inequality, it's going to be, so our first step is going to be to rewrite this inequality without the absolute value bars. I'm going to abbreviate absolute value, so ABS, absolute value. All right, so we have, since it's less than, we're going to have our absolute value is going to be sandwiched in between 2, but not including 2. Well, this is just now a linear inequality, and we know how to solve these. Matter of fact, this is a really easy linear inequality. All we have to do is add 5 to both sides, so excuse me, all 3 sides. So we'll add 5 to everything, and we have 3 is less than x is less than 7. By the way, if this had been, let's just say this had been a negative x instead. Right? So negative 2 is less than x, negative x minus 5 is less than 2. Right? So we would have, again, added 5 to both sides. That would have given us 3, all 3 sides. 3 is less than negative x is less than 7. But now we have a negative on our x value there, and we know when we multiply or divide an inequality by a negative, we need to change the direction of the sign. So if this had a negative on that x instead, we would have negative 3 is greater than or equal to x is greater than or equal to negative 7. And that makes sense, right? We wouldn't make sense the other way around, right? Because negative 7 is smaller than negative 3, not larger. All right, let's do one more. All right, so let's solve the inequality. The absolute value of 3x plus 2 is greater than or equal to 4. All right, this time we're greater than. So our first step is going to be to, oh, we didn't graph it. Let's go back and graph our inequality. So we rewrote it, we solved it, let's graph it. And let's get a line tool. Well, other than being a little crooked. It's not too bad. There we go. All right, so, and it's this one we're going to be graphing. This was just a bonus. So bonus if x is negative. And so x is sandwiched in between 3 and 7 and does not include 3 and 7. It does not include 3 or 7. So 1, 2, 3, 4, 5, 6, 7. Open at 3, open at 7, connect in between. There we go. All right, now we can do the next one now that we've graphed it. All right, this one, solve the inequality. This one is a greater than or equal to. So that means that, so first step is going to be to rewrite the inequality. So we have 3x plus 2 is either less than or equal to -4, or 3x plus 2 is greater than or equal to +4. So with the less than, we're sandwiched in between. With a greater than, we're either less than the negative or more than the positive. All right, in this case, it also equals because we have an equal sign there. All right, so now we're going to solve the two separate inequalities. But notice that solving an absolute value inequality, if what's inside the absolute value bars is positive, right, is just the same as solving a linear equation. You just are solving two of them. Now, we won't be doing absolute value of quadratics this year, but you will see it next year in calculus. All right, so now let's solve this one. We don't have too much to do here. We're going to subtract 2. So we have 3x is less than or equal to -6, and then divide both sides by 3. So x is less than or equal to -2. Over here, we have, we're going to subtract -2 from both sides. So we had 3x is greater than or equal to 2, and then divide both sides by 3, so x is greater than or equal to 2/3. Notice they're not the same, right? And that's because we didn't just have the absolute value of x is greater than or equal to 4. Then it would have been -4 and 4. We had stuff with the x, so that makes those two values not the same, but we still set it up as whatever in the absolute value bars less than, and in this case also equal to the negative, and greater than or equal to the positive, because we want to be more than 4 away from the origin. So our solution, and let's see, I'll just start at -4. -3, -2, -1, 0, 1, 2, 3, 4. So we have an open circle at -2, a closed circle at -2, right? Because there's an equals, so equals is closed circle. That point is included. And then also a closed circle at 2/3, and that's right about there. Right? And we want x is less than -2, so it's all of this, or more than or equal to 2/3, so it's all of this. So notice with the greater than, this will always go in opposite directions. So if you have a greater than, the inequality goes in opposite directions. If we have a less than, and either one of them could include equals to, the inequality is sandwiched in between two values. Right? And so long as you know how to set them up, these are actually pretty easy to solve. And that's the end of this podcast on absolute value inequalities. In the next podcast, we'll do some real world problems. Thanks for watching. Bye for now.